In this video, we're going to look at maximizing monopoly profit with a nonlinear demand curve. In particular, we're going to be looking at a monopolist that has a constant elasticity of demand. So here is the setup. The demand for the monopolist, you'll note here, is nonlinear. Quantity demanded equals 100 multiplied by p raised to the minus second power, which can also be written as 100 divided by p squared. So this is a constant elasticity of demand. What's nice about this is that elasticity is constant along this nonlinear demand curve, and it'll just equal whatever this coefficient here is, whatever price is raised to. So in this case, elasticity of demand is -2 throughout this demand curve. Let's assume this monopolist has a simple marginal cost structure. Marginal cost is constant at $1. There are two ways you can solve this problem. Perhaps the easiest way is method one. Method one, however, relies on you recalling that marginal revenue can be given by this formula. This is something that can be derived, and I believe that I derived this in another video. I'm not going to do that here, but marginal revenue equals price multiplied by what's in parentheses, 1 plus 1 over the elasticity of demand. So I'm just going to set this equation equal to marginal cost. This is the marginal revenue equals marginal cost approach. So for elasticity of demand, we're going to put in -2, which I got over here. For marginal cost, we set that equal to 1. And now we simplify, and we get price equals $2. Plugging this $2 back into our demand curve, we're going to get 100 divided by 2 squared, which will just equal 25. So the profit maximizing price for this monopolist is $2. The profit maximizing output equals 25 units. So one way to solve these nonlinear demand equations. In the next method, we're going to do maybe a more traditional approach. In this approach, we'll get total revenue, take a derivative to get marginal revenue, and then set it equal to marginal cost. So what I want to do, I want to take this demand equation and solve for price. So moving down here, p squared equals 100 divided by q. Multiplying both sides through by p squared, dividing both sides through by q, we get this. And then taking the square root of the right-hand side, square root of 100 is 10, and then we're just left with the square root of q. To get total revenue, we want to take price and multiply it by quantity. So price times quantity, what's price? Well, 10 divided by the square root of q. That's multiplied by q. That will leave us 10 multiplied by q divided by the square root of q, which will just simplify to 10 times the square root of q. The next step is to take the derivative of this result to get marginal revenue. We do that. We're going to bring down the 1/2 in front. So 1/2 times 10 is 5. Then it's going to be 1/2 minus 1 in the exponent, leaving us with -1/2. And that can also be written as 5 divided by the square root of q. Setting marginal revenue now equal to marginal cost. So here's our marginal cost of 1 again. So marginal revenue equals marginal cost. Just multiplying both sides through by the square root of q. And then squaring both sides. The output here is 25, as we saw in the previous screen. What's the price? Well, we can go ahead and plug this output into the price equation. So 10 divided by the square root of 25 is 10 divided by 5, or $2. And that's it. I hope you found this video helpful.